Alright lads, let's prove the product rule from Calculus 1. Right. First things first, we're going to apply the limit definition to solve for it. So the derivative could be expressed as the limit as h approaches 0 of f x plus h minus f of x divided by h. And we're going to apply this to our product basically in terms of f of x, g of x. So we're going to rewrite it using the limit definition as shown on the screen. So this is how it's going to look, right? But before we continue, we're going to have to apply a little trick, and you see why in a moment why we have to do this. So the reason what we're adding into the equation is these equations are completely the same. This term and this term, when they're added, is going to basically render, it's basically equal to 0. The reason why we need to introduce this is to, essentially factor the equation and simplify it. It basically makes this equation render it much solvable. So we're going to have to factor out an fx plus h. Notice this has got an fx plus h, and this term as well has got one. So we're going to have to factor that out. And then we got the addition. Notice here this is g of x and this here is g of x. So we're going to factor out the g of x term. And we're basically going to have the equation rewritten as the following. So the next step is basically to split the limit into 4. So that's what I'm basically going to do. So the first part is very straightforward. We're going to have the limit as h approaches 0 of f of x plus h. This will basically be left, we'll just be left with f of x, because once you substitute the 0 in there, you're just going to have f of x. Over here is basically the limit definition of the derivative of g of x. So we can write it as this. Over here is basically just equal to g of x. And lastly but not least, is basically the limit definition of the derivative of f of x. And there you have it, lads, the product rule that's been solved for you lot. I hope you lot enjoyed this video. If this video has helped you lot, please leave a like and subscribe, and I'll see you lot later. Bye.